Welcome, students. We're going to be talking about how symmetry works. And so if you guys remember what symmetry is, we have a few forms of symmetry. The one that you guys are probably most familiar with, and the one that I would say is most common in our world, is line symmetry. That is, that if you drew a line and folded the thing in half, it would fold symmetrical, be the same on both. And you notice right here, there's this bug. If you fold it in half right there, the legs would fold off. Same thing with this shape. You fold it, it'll be this. This is called line symmetry. And this definition is pretty key. A figure in the plane has line symmetry if the figure can be mapped onto itself by a reflection in a line. Okay, that's the axis of symmetry right there, AOS. So there's a couple figures. Yes or no, how would you do it? So this line symmetry, this, this. All right, yes or no, where are the lines? Now the secondary one, so there's going to be a worksheet. I want you to finish the first half in class, before class, and in class after the video, after 10 a.m. we will finish the second half. The second half will follow this rotational symmetry. So the first ideas are line symmetry and kind of yes or no and drawing the lines. The second is rotational symmetry, which is if you rotate it a certain amount of degrees, it will rotate onto itself. Okay, that's rotation. The center of symmetry will be where you're rotating from. So in this case, this is the center of symmetry, rotating at 45 or rotating at 90. Now 45 does not map onto itself, right? This is a different shape. This is different location than this. But when you rotate at 90, 180, and 270, this shape is onto itself. It looks the same, okay, right? This looks the same as this, looks the same as this, looks the same as this, right? That is its symmetry. Now, order of symmetry is the number of times a figure maps onto itself as it rotates from 0 to 360. It is called order of symmetry. So the number of times, how many times did this rotate onto itself between 0 and 360? Well, this rotated 4 times. You start with the 0, 1, 2, sorry. So you start with this 0 degrees. So this is 1, 2, 3, 4. So the order of this order of symmetry is 4. Now magnitude is just 360 degrees divided by that 4. It tells us the smallest angle we can rotate by. And that is a magnitude of 90 degrees, right? 360 divided by 4 is going to be 90. Okay, looking at these examples, we can see this one, yes, this is going to rotate, and it's actually going to rotate 6 times, right? Each angle between these two is going to be sufficient for it to rotate onto itself. That's going to be 6 times, so then what we do is that's an order of 6. So it has a magnitude of 360 degrees divided by 6. Or it's 60 degrees from the center that this rotational symmetry will be. This shape does not have an order of symmetry or a symmetry of any value. So this would not have any place. Another example, this figure right here has 2 symmetries. One is going to be right, if I'm not mistaken. Oh, yes. So if you rotate it 180 degrees, it's going to give us. So we're going to have our 0 degrees and our 180, or 180 and 360. Either way, you're going to rotate it twice. And so that's going to have 180 degrees as your rotation. Okay? So there's some more examples of whether it has and what the line, whether it's line symmetry or rotational symmetry, okay? Okay, that is going to be it. So the rest of class is going to be working on symmetry. We do have our test on Thursday, so in class we'll talk about the test. I have graded your previous test, and I hope to post the grades. It was a little complex because of how the Google form and Delta Math interacted. But know that it will be posted, and you should be able to see your grade here today. Thank you so much. I will see you guys later. Bye.